Hi everyone, we're going to start a new chapter today. I hope you all had a lovely break. I think, I think this is the last mechanics chapter. '12 or 13, yeah, I think so. So after this, we're going to be going into heat and temperature. So that'll be nice because we've done a lot of mechanics now since the start. When I am back in, I will give you back your Christmas exams and go through them and stuff, but while I'm not in, we may as well do this. So this chapter is, I think, similar to the last one. Was the last one split in three? Yeah, pressure gravity moments. So this chapter is the same. There's three parts to it: work, energy, power. The reason they're grouped together is because there's kind of a relationship between them, I suppose. There's a connection between work, energy, and power. Okay, so we'll start with work. So me coming to work today, or you guys, if any of you have a job, going to work, it's got a different meaning in physics. So in physics, in order to be classed as doing work, sorry, my pen's not working. So in order to be classed as doing work in a physics sense, you have to exert a force and cause an object to move through a distance, or displacement, more specifically. Okay. Sorry. Okay, it's going to be in rainbow. So you must exert a force and this force must cause an object to move through a displacement. Is that okay? So that's that's work in the physics sense. Okay, it's very important that when you exert the force, that whatever the object is you're attempting to move, that you move it. Okay, so whether that is we know that a force is a push or a pull. We know that a force can cause a velocity to change, so sometimes a force just causes a change in direction. So once the object moves, then you have done work. Okay, so given it's dependent on force and displacement, you'll see it down here. So here, and this is in the formula and tables book, work is equal to force multiplied by displacement, or Fs. F is force, S is displacement. Okay, so we'll have a quick look at the units. So work is equal to force by displacement. The unit for force, newtons. The unit for displacement is meters. So that means the unit for work is the Newton meter. Okay, now like in some of the ones we've come across before, the Newton meter is the compound unit, so that's the unit we've just built using the formula. But a lot of the time, remember when there's a scientist who puts a lot of work into a particular area, the unit gets renamed. So work is one of those, and it's been renamed the joule. Okay, so the unit for work, if you build it, is force by distance, so it's newtons by meter, so Newton meter. And we don't use Newton meter, we use the joule. Okay, it's just J. That does not look like a J. Yeah. Okay, so we'll have a look at this couple of problems. Should be okay, I think. Find the work done when a horse exerts a horizontal force of 400 newtons on a cart and pulls it 20 meters in the direction of the force. Okay, so it says find the work done. So we're going to get our formula for work. So into the formula in tables book, work is force by distance. Okay, work is our unknown, so leave that as W. Next we have F. So F is the force, and it says here a force of 400 newtons. Again, don't forget to check your units. So newtons is the correct SI unit for force, so that one's fine. So we say 400, and then S. S is displacement, and it says here that the cart pulls it 20 meters. Okay, and displacement is in meters, so that's 20. So you just do 400 by 20, and we get 8,000, and that's joules. Yeah? Okay, let's go this one. Find the work done in raising an object of mass 5 kilograms through a vertical distance of 10 meters at a steady speed. If this is repeated 50 times, how much work is done? Okay, so first of all, we have to do the work done in raising the object, just the once, and then you have to figure out the work if you do it 50 times. Okay, so it's still find the work done. So it's still going to be work equals force by distance. Now, the force. So you can see the guy in the picture, and he's going to take whatever the object is he's carrying there, and he's going to bring it from the bottom of the stairs to the top of the stairs. And we need to know the force. So essentially it's the force he's bringing up the stairs, or the force he's going to have to put in order to bring it up the stairs. Okay, they're the same thing. So it's because of Newton's third law, so every action has an equal and opposite reaction. It's the force of the object he's carrying, and we'll talk about that in a second, or it's the force he has to exert to carry it. Okay, so because if he doesn't exert that force, he'll drop it. You know, I don't want to say it, but anyway. Okay, so what is the force we're talking about here? So all we've been told is that it's a mass. We've been told it's a mass of 5 kilos. So how do we make that mass a force? So hopefully you're usually quite good at this. So yeah, in order to turn a mass into a force, we need to turn it into a weight, because weight is a force. And to do that, we need to multiply it by gravity. So in order for that man to carry that object, as in for the object to be off the ground, he's going to have to exert a big enough force to counteract gravity. Okay, or you look at it from, it depends whose point of view you look at it. Maths wise, it makes no difference. You look at it from the point of view of the man, he's carrying that mass. So in order for him to carry it and for it to be off the ground against gravity, he's going to have to exert a force big enough to counteract its weight. Okay, so that's why you calculate the weight, you multiply 5 by 9.8. Or you look at it from the point of view of the bag, as in what force is it exerting on the man, and the force is its mass by gravity. Yeah? So it makes no difference which way you think about it, but either way, it's not mass that goes in. It has to be force, and force is weight. So that is, that's 49 newtons. So I can put that in here now. So W is 49. Now, the S. Let's go pink. Okay, so we know that the S stands for displacement. Okay, and this is where the fact that it's displacement is important. So the guy is carrying the bag up the stairs. Okay, when we're talking about calculating the work that he's done, essentially all that matters is kind of the amount of gravity he has had to counteract. How much gravity did he have to work through, I suppose? So he's exerting a force to keep that bag off the ground. And we need to figure out the displacement that he carried it through. So the displacement is, if you remember, the straight line distance, the as the crow flies distance. So it's where did the bag start and where did the bag end up. Okay, you can see from my green lines over here, the bag started here and it ended up here. It doesn't matter that he actually walked up a diagonal path. That doesn't matter. Okay, because the formula is force by displacement, it's where did he start and where did he end up. So it's going to be, in this situation, because he's going upstairs, it's going to be a vertical distance. Is that okay? So the distance travelled, hopefully you can see that there's no calculation needed, but it's 20 metres. Okay, so we don't take into account the fact that he walked up the stairs, up that diagonal distance. It's a displacement, so all we care about is the fact that he carried that against gravity for a 20 metre vertical distance. Okay, so that's what I put in here. And that's going to give us 980 joules. So it's going to, he is going to have to do 980 joules of work in order to carry that bag up to the top of the stairs. If he does it once. So if it's repeated 50 times, just multiply by 50. So that should be 49,000 joules. Yeah. Sorry, just want to see if there's. Okay, that's pretty much exactly the same. He's carrying 50 kilo bag up the stairs, so that's the same thing. The vertical height for which it rises is 20 meters, and he exerts an upward force on the bag equal to its weight. So that's what I was talking about. When you're calculating the force, you either look at it from the point of view of him exerting the force, or you look at the point of view of the bag, in which case you calculate its weight. Either way, you're going to get the same thing, and then find the work done by the man on the bag of cement. So that's fine. Okay, let's have a little look at this one. This one says, find the work done in bringing a 1,000 kilogram car from rest to 30 meters per second in 10 seconds. Okay, so there's a bit more work in this one. Haha, pardon the pun. So find the work done, so it's still going to be work as force by distance. Yeah? Now, again, the force. So you can see here, 1,000 kilograms. You've been given a mass. But we know how to turn a mass into a force. We simply turn it into a weight, because weight is a force, and we do that by multiplying by gravity. So we take the thousands, multiply it by 9.8, and we get 9800 newtons. Okay, and that's this over here. Yeah? Now, the S, the displacement. We have not been given a displacement. We've been given this stuff. We've been given that it went from rest. Oh, not, sorry, the word from is not a key word. From rest to 30 meters per second in 10 seconds. We've been given these 3 pieces of information. Oh, I wish I was there to see if you could get these. That type of language, starting from rest, travelling to a particular velocity in a certain time. We did that with the equations of motion. Do you remember them? So V equals U plus AT, S equals UT plus a half AT squared, V squared equals U squared plus 2AS. Remember these? So we're trying to get S, and what do we have? So rest, starting from rest, is your U, up to 30 is V, and 10 seconds is T. And we're looking for, we're looking for S, so we're looking for displacement, because that's what we need to fill in our work formula. I think it's the last one, is it? Have V, have U. Oh no, we're going to have to do 2. Ugh. So if you look at the last one, we have V, we have U, we don't have A. And if you look at the second last one, we have U, we have T, we don't have A. So either way, we're going to have to figure out A. Okay, so if we use the first one to figure out A, I think. So V equals U plus AT, which is 30 equals 0 plus A by 10. So 30 equals 10A. We want the A. So we divide by 10. So then A is 3. And then we can use either of the other two. So I suppose I'll go with the second one, just so I don't have to rearrange. So UT plus a half AT squared. So U is 0, T is 10, plus a half. We now know A is 3 and T is 10, and we square it. And because I don't have to rearrange, I can just throw that into my calculator. So I'm getting 150 meters. Okay, so now I know the distance. I can go back in and put the 150 in over here, and then that's it. So the work is 147, 1, 2, 3, 4 joules. Okay, so I suppose just to be aware that mechanics is just one big, well, physics is one big field of study, but mechanics in particular, so you might have to reach back into theory that you've done before and use it. Like, you know, we had to solve that problem and we had the equations of motion and the language, that idea of the car accelerating from rest to 30 in 10 seconds. that's all the stuff we did when we were doing that acceleration chapter, and in that acceleration chapter were the equations of motion. So basically all of the formulas I've ever taught you are kind of up for grabs, so don't kind of be afraid to use them, I suppose. Yeah. Okay, so that's work. That's the first part. And then tomorrow we'll go on and do the energy part, although I don't know that I'll finish it because there's a bit more in the energy part. But yeah, that's work. Okay, so exerting a force, and that force causing you to move an object through a displacement. If both of those things happen, in the physics sense, you have done work, or the object has done work, if it's capable of it, like the car in the last one. Okay, so let's have a look. We got a couple of good ones. So hopefully you'll finish them in class today, but if not, do make sure you complete them. Three. Six. And let's go 9. 3, 6, 9. Didn't plan that. I'm going to put these into the journal. So I need a new page, I do. Okay, so these are in the journal. You can give them a go, and when you're done, throw them onto the assignment on Schoology. Alright, and I will talk to you again tomorrow. If you have any questions on any of that, just send me an email and I'll get back to you. If I have to make a video or whatever, so I can talk to you, I will get back to you. Alright? Okay, talk to you soon.